Hi. So today I'm going to demonstrate an example uh, for a Kubernetes network problem. And so in my last video, I used the IP table trees to find the cause for the Kubernetes networking problem. In this example, the IP table trace is not going to be very useful because the networking issue here happens between the pods, between multi-node cluster. Um, so because the pod network communication between the cluster node happens in a VXLAN tunnel. So the packet is encapsulated in a VXLAN tunnel. So the IP table trace will have no visibility to the packet in the VXLAN tunnel. So to demonstrate that problem, I'm going to use the nginx controller as a deployment example. So the nginx controller you can deploy in a multi-node Kubernetes cluster. So this is a link like to explain the nginx controller in multi-node Kubernetes cluster. So I already deployed that in my lab. So here is my lab. Here is my lab. I have two nodes in the. I have two nodes in the Kubernetes cluster. One node is called a controller worker. Another node is called a localhost, and they all have the. So I deployed an nginx controller pod, so we can see nginx controller pod is running for most of them. But as you can see here, there is a API gateway pod in a CrashLoopBackOff state. So this is not good, and we needed to find out what the problem is. Okay. So I just sent some kubectl command for too easy to navigate the Kubernetes cluster system. So let's use this command to just list the API gateway pod. And so this API gateway pod is running fine. It is in the localhost node. And this API gateway pod is in controller workload in CrashLoopBackOff. So that's not good. And then let's find out. We can log this fading pod and see if that's anything interesting. So it has an error, host not found in resolver kube-dns kube-system. So this resolver is not found, and this resolver is configured in nginx.conf file or in the API gateway pod. Okay. So by the way, the API gateway pod is a pod runs a nginx instance, and it serve as a gateway to other nginx controller pod services. Okay, we can actually look at this nginx.conf file in the pod. So, but since it's in CrashLoopBackOff, we cannot get a shell to this failing pod, but we can look at this working pod and API gateway pod, see what the what this nginx.conf look like. Okay, so I also have a command for that, and so we can use this kubectl, get a shell, cat the nginx.conf file. Okay, so this is the nginx.conf file in the API gateway pod. In number 911, so we give the number 911, and that's the configuration line here. This says resolver kube-dns kube-system. So what is a kube-dns? So it is the default DNS services in a typical Kubernetes cluster system. We can actually describe this services kube-dns. Okay, so it's the DNS services, and it has two endpoints, which is core DNS. Okay, so the core DNS pod provide DNS services in Kubernetes system. We can look at the core DNS here. So this command will show us the core DNS pod. Okay, so two core DNS pod running in the localhost node. Okay, so back to this error. What this error means is that the nginx instance in the API gateway pod cannot resolve this kube-dns services. So it seems there is a DNS resolution problem, right? And so how do we find out? So we needed to have a packet capture for the DNS resolution to see why it cannot resolve this kube-dns. Okay, so but then you ask why we don't use iptable trace to trace the packet. So the reason the iptable trace will not be useful here is that as I said earlier, the communication between pod between node is through a VXLAN tunnel. For say in your Kubernetes cluster system, if you use a Finino VXLAN as a tunnel to for the pod communication between say API gateway pod here in node controller worker and core DNS pod in node localhost. So in this scenario, both core DNS pod runs in the node localhost. There's no core DNS pod in this node 2 controller worker. So for this guy, API gateway that is crashing loop, this API gateway needed to contact the core DNS here in node localhost, right? So that I draw a simple diagram here is show that since it's pod communication, the traffic goes through the first goes through the CNI 0 bridge. That's a bridge interface on the Linux host, and then it goes to a final .1 interface. That's the VXLAN interface for final, and then it will do the encapsulation. And this is the physical interface. This is the physical interface. So when the packet is going through the physical interface, it is encapsulated in VXLAN tunnel. So so the IP table letter filter chain will not have visibility to the packet that is encapsulated in VXLAN tunnel. So the tracing will not help here, but we can run tcpdump. We can run tcpdump at 2 point, at a two interface here, right? So we can run tcpdump on this bridge interface. So we will see the packet. So any packet egress from the pod through this bridge, the packet will not still not encapsulated. It's still the original pod traffic. But if we run TCP down here on the physical interface, the packet will be encapsulated in VXLAN tunnel, and so we can check if there's a network issue here, or if there's a network issue here, and we will see why the DNS resolution failed, right? So okay, let's do that. So actually, to save time, I already have the capture here, and I can show you. Okay, so this is the capture, TCP-dump capture on the CNI0 interface, and so this is my okay, yeah, so it's better. So this IP is my API gateway pod source IP, okay? And yeah, in the diagram here, let's see. Okay, this is my API gateway pod, and that's the .184 source IP address, and this node has the subnet 10.244.1/24 subnet. Okay, so that's the API gateway pod source IP that is in CrashLoop. Okay, so this is the core DNS pod IP 10.244.0.39. Okay, that's this core DNS pod in node localhost. Okay, so here. right? No, yeah, this is not a, because I'm running I redeployed the lab again, so the core-dns IP changed this time. My capture is for previous deployment. That's fine. We can still use the old capture here, and also my diagram here still has the old API gateway IP and the core-dns pod IP. That's fine. We can just demonstrate the problem here. In the capture, so this is the capture on the CNI0 bridge, and we send the DNS query for kube-dns to resolve this resolver address, and you can follow UDP string, and it's two query, but we did not receive DNS response for kube-dns.kube-system, right? And so this is a capture on the CNI0 bridge. That's the capture on this here, on this. So we still have the original packet that's not encapsulated. So now let's look at the capture in this physical interface. Okay. So this is the capture on the physical interface, and it's going through so that's the this is the packet that got encapsulated. Okay, so encapsulate on the physical interface. As you can see here, we have a virtual local area, virtual extent VXLAN header here for the outer packet header. Right. So pay attention. See in the encapsulate the packet. So this is the inner packet that is encapsulated. So this is the outer packet IP header with the physical interface IP address. So this is the inner IP header for the pod. So notice the pod IP is changed to 10.244.1.0, and so this destination IP is the core DNS pod IP, right? And so this final interface has the 10.244.1.0 IP address. So when the packet passes through this bridge interface, coming here through the physical interface, the packet is encapsulated and the source address is changed to the IP address on this final VXLAN final interface. Okay, and all right. So let's follow UDP stream. It looks like we received the DNS response for kube-dns, right? We got the answer. The address is at here, .10, and so we received the DNS response on the physical interface, but we did not see the response on the CNI0 bridge interface. We only see the query. We didn't see the we did not see the response. So it looks the packet got dropped after receiving from the physical interface, right? So it looks like we found the problem. And so what's the problem? The problem is actually I still have firewall D running on the controller worker node. Okay, so maybe it's firewall, right? Blocking the dropping the packet. So we have a firewall with port allowed 6443 2379 2380. So that's the port for the Kubernetes cluster etcd daemon. So this is for the API Kubernetes API server port. So as you know, that the nginx controller are deployed in multi-node Kubernetes cluster, and all the nodes are master node. They're actually they are all master node. So they also have API gateway server listening. And so it looks like let's look at the VXLAN packet again here. Look at the outer, look at the outer IP header and the TCP header. Okay, so this is the outer IP header for the physical interface IP address. And this is the UDP protocol, right? And okay, here is the UDP, outer UDP header for layer 4, and the destination port to the localhost node is 8472, right? So what is 8472? The destination port. That's the destination. That's the port for Linux VXLAN tunnel. And so this is the port for the VXLAN. But in our firewall D, we do not have this port allowed. We do not have the 8472 port allowed. So maybe that is a problem, right? We can confirm, since I have firewall D log deny enabled, and then we can see if there is a deny message, reject message for 8472. There are not, and okay. So as you can see here, the destination port is 8472. It's got a rejected, right? So it likes we already found the problem, and we can open this port, right? So we can add this port. For the VXLAN, we renode. Okay. So let's check if it's allowed. Okay, it's added here, UDP port 8472. Okay, let's report this workload. So again, this is a simple diagram for VXLAN tunnel communication between the pods in Kubernetes cluster. And yeah, so I have a more in-depth, I believe, analysis for the VXLAN. Yeah, so I have some previous video to explain how the packet passing through the VXLAN tunnel. So this is like 2 years ago video, if you are interested to watch. So we reported to the work node. Has it come up? It's coming up. And let's look at the pod. See if it's running. Let's remove this one. I think this is the old one. Okay, so this is a new pod, right? That's the new pod. Now it's running in the controller worker node, right? So looks like we resolved the problem. So this is we can look at the worker node with same command, right? So same node, same pod, and running. Okay. Yeah. So in summary, I just show you example like when to use tcpdump or when to use iptable trees to solve the Kubernetes networking problem. And so if you have a networking problem between pods that is in different cluster node, and also if you happen to use a VXLAN tunnel, so the tcpdump would be useful tool to troubleshoot the networking problem. But if we have Kubernetes network problem that the net filter has visibility, you can use iptable trees to look for the problem. And yeah.